Okay, so this energy tutorial question number 3. Let's think about how we might go through this. Let's go through it in the order you've been asked to do it. So part A, first of all, that's the first thing we're going to consider. However, before we consider the questions, I would always recommend that you extract the information and write it down in the relevant units, because that will help you. And you can also put the symbols by it. So what have we got? A solid cast iron flywheel with a diameter equal to 750 millimeters. Put it into the appropriate unit, 0.75 meters. Oops, 0.75 meters. And thickness equal to 100 millimeters, 0.1 meters. The density of the material is 7,200 kilograms per cubic meter, so that's in an appropriate unit. Go on. Yeah, so height, or yeah, T for time, so maybe we're going to use H for height or something like that. We could draw this thing. We've got this flywheel and it's got a thickness, so we could actually write on what the thickness is. So the diameter and the thickness is here, so that's H between there and there, and the diameter. That would make it clear, wouldn't it? Okay, so yeah, drawing it is usually a good idea as well. We're also given, so we've got the radius, we've got the diameter rather, the thickness, the density. It's accelerating uniformly from a speed of 100 RPM. So again, we're not actually given the speed, we're given the frequency is 100 RPM. So that needs to be divided by 60 hertz, or 10 over 6 hertz. F2 is 1,000, thank you. So that's 1,000 over 60 hertz. So that gives us frequencies of 1.67 hertz and 16.7 hertz. What else are we told? Time is 1 minute. Which is 60 seconds. And the bearing friction torque of 4 Newton meters. So torque friction is 4 Newton meters. So part A says find the moment of inertia of this thing. What's the relevant formula? I equals mk squared. Do we know the mass? No, we're not given the mass. We don't know the radius of gyration either, so we need 2 formulae for that. So from the work we were doing on the equations of motion, we've got for a solid flywheel, the radius of gyration equals the radius divided by root 2, r over root 2. So we can find the radius of gyration k. The mass is the awkward one. And there's a formula that we've not actually written down, but it's a very basic formula that relates mass, density, and volume. Anybody remember it? So basic formula for density is mass over volume, and we can get that from the unit. Because we measure density in kilograms per cubic meter, that's actually telling us the formula, mass over volume. Okay, so we want the mass, so therefore mass equals the density times the volume. Now, we're given the density of this material. It's 7,200 kilograms per cubic meter. We're not given the volume though, but we know what shape it is. So what is the volume of a cylinder? The formula? Pi r squared, the area of the end, times the length. Yep. Do we know the radius? Yeah, we do in a way because we're given the diameter. And do we know the length? Yes, that's the thickness. Okay, so we can find the volume. Once we've got the volume, we can find the mass. And then we can plug those two things, the mass and the radius direction, in here to find the moment of inertia. So would you like to go ahead and do that? Go there. So putting the values in, we get the radius is half the diameter, 0.375. So the radius of gyration is going to turn out to be 0.265, the three significant figures. The mass, density times pi r squared L, leaving the accuracy in there as we can. We can do it in one hit. Get about 318.1 kilograms. So four significant figures. Then putting those figures in, we get a moment of inertia of around about 23 kilogram meter squared to two significant figures. And that's a reasonable accuracy considering the significance of the initial values we're given, which is round about one or two significant figures. Okay.